Hello everyone, in this video I'm going to speak about enthalpy change. Let's get started. In our curriculum, we will study the enthalpy change for three types of reactions. The first reaction is the combustion reaction. First of all, we have to know what's meant by combustion reaction or what's meant by enthalpy change of combustion reaction. We all know that the combustion reaction is the reaction between a substance with oxygen. If we have hydrocarbons, it should produce carbon dioxide and water, as you can see here for the combustion reaction of methane. We have methane plus oxygen, give carbon dioxide, water, and of course heat. So the amount of energy given out when 1 mole of substance is completely burned in oxygen is representing the enthalpy change of combustion. Is it exothermic or endothermic? It's clear that it is exothermic. From the delta H, it's negative, so it's exothermic. This is number one. Number two, all combustion reactions are accompanied by heat release, or heat is given out from this reaction, so it's always exothermic reaction. We'll never have endothermic reaction for a combustion reaction. For that reason, we will always have to care about the negative sign accompanied by the delta H of combustion. The second type of reaction is called solution reaction, enthalpy change of solution. What's meant by solution reaction, or what's meant by the enthalpy change of solution? It is the enthalpy change when 1 mole of solute is dissolved in excess solvent. And we can have an example here where we have ammonium nitrate, NH4 NO3 in excess water. We will have NH4 positive, NO3 negative. This type of reaction, or this example, in this example, delta H solution is positive. Does it mean that all solution reactions are endothermic? No, they could be exothermic or endothermic. Like when we dissolve sodium hydroxide in water, it will give out heat, so it could be endothermic or exothermic reaction. For enthalpy change of solution, we could have exothermic or endothermic reactions. Okay, the third type of reactions that we will study its enthalpy change is the neutralization reaction. In the neutralization reaction, it represents the enthalpy change when 1 mole of water molecules are formed when an acid H positive ion reacts with an alkali, which is represented by OH negative. As you can see here, H positive plus OH negative is producing water, and we'll care a lot about the water produced when we will speak about how can we calculate delta H for neutralization. So what is it exothermic or endothermic reaction? It is always exothermic. It's always exothermic. So to summarize what we have covered here, combustion is always exothermic, is always accompanied by negative delta H. Enthalpy change of solution, it could be exothermic or endothermic. We could have positive or negative delta H. Neutralization is always exothermic, accompanied by the formation of water from the reaction between H positive and OH negative. Now let's speak about how we can calculate the enthalpy change delta H. If you have in your problem or in your question sufficient data about the mass and number of moles, then you will need to use this formula. Delta H is equal to Q over N. What is Q? Heat. Is mc delta T over N. So we have here M, which is the mass, C, specific heat capacity, delta T, temperature change, then we have N. It's a bit confusing for some of you. What is M? What's the difference between M and N? M is for what and N is for what? M is the mass. Mass for what? Mass for the substance affected by heat. Substance affected by heat. And we'll speak now about the different substances that could be affected by heat based on the type of reaction. Then we have here number of moles, N, number of moles. Number of moles for what? For the source of heat, source of heat. Okay, let's go ahead, speak about our three types of reactions. We have combustion reaction, we have combustion reaction. Okay, we have to agree about some things, which are C, specific heat capacity. C is specific heat capacity, and it's always 4.18 for water, and it's given the booklet, so you don't have to worry about specific heat capacity for water. If you have been given another substance, they have to tell you the specific heat capacity. Delta T is the temperature change, and it will always be clear in the question. So maybe the most confusing parts in this formula is M. What is M and what is N? First of all, and as we have agreed before, that we have combustion reaction, we have here combustion reaction, we have solution reaction or dissolution reaction, and we have neutralization reaction. For the combustion reaction, M is always for the substance affected by heat, which is always water. So don't forget about that. So the mass of water. What if we're not given mass? If we were given volume, okay. If we were given volume, let's say that you were given 100 cubic centimeter. It is same as 100 grams. Why is that? Because the density is 1. So it's a valid assumption here that we use the mass or use the volume as mass. 100 centimeter cube is equal to 100 grams because the density for water is 1. What about the number of moles? Number of moles is always for the source of heat. What source of heat in the combustion reaction is number of moles, so it should be the moles for the fuel burned. The number of moles for the fuel burned. It could be ethanol, methanol, any other fuel burned, and we have to always consider N is equal to mass over molar mass. That's how you can calculate the number of moles of the fuel burned. Okay, let's go ahead, start speak about the solution reaction. We have here for the solution, mass is always for the solution itself. So if you have been told that you are dissolving, let's say, sodium hydroxide in water, so yeah, you have the solution, which is water. Let's say they are telling you you have 100 cubic centimeter. As we agreed before, we will use the volume as the mass, 100 grams, because we have a valid assumption to say that the volume is same as mass because density is equal to 1. What about the number of moles? Number of moles, or N, is moles of the solute. Moles of the solute. So if they are telling you that you are dissolving magnesium, you are dissolving sodium, you are dissolving sodium hydroxide, then you need to calculate the number of moles of the solute itself using the formula N is equal to M over MR, mass over the molar mass. Okay, then for neutralization. For neutralization, it is a bit different because we have M, mass, is equal to the volume of acid or the mass of acid plus the mass of base. So here it should be the amount of acid plus the amount of base. As we agreed before, we use volume as mass. So if you have been given 100, let's say 100 centimeter cube acid, 100 centimeter cube base, then your mass should be 200 centimeter cube, or we can say 200 grams. Okay, knowing that the density is 1. What about number of moles? N is for the water produced. N here is for the water produced from the neutralization reaction. Water produced from the neutralization reaction. What's the neutralization reaction? We have acid. If we have acid plus base, it should give you salt and water. So the number of moles of water produced should be N. The number of moles of water produced from the acid-base reaction should represent the N. So again, we have three types of reactions. We have combustion reaction, we have solution reaction, we have neutralization reaction. To calculate delta H, we have delta H is equal to Q over M. What is Q? MC delta T over M. Delta H is representing the enthalpy change in heat, Q, heat change, M for mass, C, specific heat capacity, delta T, temperature change, and number of moles. This formula could be negative or could be positive based on the type of reaction. If we have combustion reaction, it has to be negative, delta H should be negative, and if we have neutralization reaction, it's always negative. It could be negative or positive when it is solution reaction. When it's solution, it could be negative or positive. Okay. For the combustion reaction, as we can see here, for the combustion reaction, M is for the volume of water in cubic centimeter. And we have said before that we can use the volume as mass because the density is 1, and it is a valid assumption. If you have been asked about giving a valid assumption for this reaction, you can say that the volume is same as mass because the density is equal to 1. For solution, volume of water also. For neutralization reaction, it is volume of acid plus volume of base in cubic centimeter. C, as we can observe here, C is always for water, or as it will be given in the formula. For N is a little bit different. Because for the combustion is, again, it's not different, it is the same. It is N should be for the source of heat. What is the source of heat in the combustion reaction? It is the alcohol parent, so it is the number of moles of alcohol parent. What's the source of heat for the solution reaction? It is the solutes, the substance that will dissolve in the solvent. Okay. What's for neutralization reaction? It is number of moles of water from the equation. So I have to write an equation to figure out the number of moles of water produced from the acid-base reaction.